which tries to forward the mission of universal access to all knowledge. We have millions of books that we make available on archive.org and openlibrary.org. We host the Wayback Machine, which has hundreds of millions, actually hundreds of billions of Wayback snapshots going back to the year 1996. And then TV new archives, and on Fridays, if you haven't had enough of us, you can email us in advance and try to get on the list for a Friday lunch. And then Rooster also gives a lovely tour of the break room and all of the machines that we have there. Some other cool things that are up and coming, in addition to the decentralized web, you might be interested in joining us on January 25th. We're having a grand reopening of the Public Domain Day. That is here at 10 a.m. We're going to have Cory Doctorow and Lawrence Lesnick and a bunch of other amazing pioneers of our time talking about the grand reopening of the public domain, which is 1923 items finally making it into the public domain, which is something that, as an institution championing universal access to all knowledge, we're very happy about. And also, later that night, there's an event, Quantopia. On all of these tables, you can find cards to get more information about the details. That's going to be at Yerba Buena. DJ Spooky is going to be DJing, and that's at 7:30 p.m. at Yerba Buena. Okay, so really quickly, we're going to try to keep it to like 15 seconds, more of like a rapid fire, one line for each question. But I would love to hear your name and project, if there's one you work on. You don't have to answer all these, but also your favorite DWeb project other than yours, which can be like a short, like, it's got to be DAT because yada yada yada, or it's got to be gun because yada yada yada. And then finally, something that we would love to know is everyone has a different idea of what decentralization means. It could mean privacy, it could mean security, it could mean creating a cryptocurrency that is robust to government takedowns. I would love to know, what is the decentralized web for you? And again, we're going to keep it really quick, but maybe we can start in the back row and then kind of make our way forward.
I have to start with this one. So my name is Marcel. I'm in the finance industry. Work with blockchain right now and in the innovation sector. Decentralized web, it's a hard question. I always dreamed of getting a kind of parallel protocol stack, parallel with TCP/IP, kind of overhaul everything. I think there's a big opening right now. When I grew up, we had Apple Talk and TechNet, so I then came to TCP/IP, and I lived for a time that we had multiple protocol stacks in parallel, and I still hope that we get there again with the decentralized web.
Thank you so much. And I'm going to set the precedent of saying even faster than that, even though I'm really grateful. And if you feel like you haven't had enough chance to say some of the things that you care about, we'll probably have time for 1 or 2 extra lightning talks. You can come up and kind of rail for a few minutes. Yes?
Hey guys, I'm Prateek. I work on the growth side for a Neo protocol. We're building a decentralized, scalable blockchain solution, which has sharding from day one. And I believe in the whole quotient of decentralization. Ideally, when HTTP and SMTP came in existence, it ought to be, it was to make it decentralized, but we saw these information overloads like Google, Facebook, Amazon come in and play different roles. But it's great to see, or great to get back into the groove and make it more decentralized. So that's why I'm here.
Thank you. All right.
My name is Will Tankowitz. I run Haney Capital, which is a quant fund for digital assets. Some interesting projects I think are recently are Wimble, which is kind of doing privacy-focused blockchain stuff. I think decentralization kind of is more so about kind of like user community-focused efforts as opposed to kind of like corporation-focused efforts, and so.
Excellent. And some of these technologies have really obscure names. So the more you can focus on pronouncing them well, the better the chances of their adoption. Mark.
I'm Mark. I run Gun, and I'll be talking on it later, so I won't ramble there. Outside of my own, I think I'll probably get flack for this. Steam is my favorite decentralized project because they have tons of real users on it. And then for me, decentralization is really about being egalitarian. that everybody has equal human rights and everybody has equal power to exercise authority and control.
Thank you.
I'm Abby. Up until recently, I was an engineer at Facebook working on their data warehouse and scaling that out for about 5 years. And I'm new to the decentralized web space and kind of just looking around and getting a feel for it. So I don't have much to say about it.
We're glad to have you here.
Thanks.
Hi, I'm Priya. I'm handling off the gun and I grew up in India, so yeah, I've seen the whole internet bubble, and yeah, I believe in decentralized web because that's the real thing. Sorry, I'm just get nervous when people look at me. So my favorite project is Code for Society because it's a nonprofit. They're doing a lot of ground level research. That's what I'm interested in. Thanks.
I'm Alex. I run Aura Protocol. It's a decentralized live client network. And I think decentralized internet is probably how it started. It started decentralized, where each person was actually, just like Mark was saying, an equal voice. And over time, it, due to the security aspects, we had to centralize. And I think right now we're getting back to the true place where we can each be equal and with the same security guarantees as the biggest companies. The most interesting project, I don't have the name, but I really like the research being done right now in the decentralized exchanges that can be fast, user-friendly, where we do not have to rely on centralized order management flows.
Why don't we go just to the left of Dom?
Oh, Steven?
Steven.
Hi, I'm Steven. With the Solana lab, and one project I like is called Seller Network. They have a really cool unicorn as a logo. And yeah, decentralized web for me. Yeah, just bringing your data and giving the experience back to the user.
All right. And if you all want to participate as well, feel free. We have tons of seats. Come on over. John.
Next, okay. I'm John. I do business development at Solana. I think the decentralized web for me means giving power back to the individual and allowing them the opportunity to act in their own interest and the interest of others.
I'm Rob, and I work on offshore reform, and I guess one of the decentralized projects that I'm most interested in is Matrix, is what I use as my chat meeting for a long time.
Thanks so much.
Hey guys, my name is Zane Witherspoon. I am the CTO of Dispatch, which is a blockchain protocol centered around distributed data analytics, co-founder of the Bureau, co-organizer of the San Francisco Ethereum Meetup, and some people know me as DJ ETH Ledger. My favorite project in the space, besides my own obviously, is I really like the business approach that SpankChain has taken. And they're the most prolific outside of the blockchain industry of any company that I see that is a blockchain tech company, actually being out there, getting involvement from people who don't have much exposure to tech in general. They're outside the tech industry, which is, I think, really impressive. To me, I think the future of decentralized web is an inevitability for the resistance to censorship and the fault resistance. The fact that we have sort of redundancy that keeps applications from going down and back up again. I think it's the future of the technology itself.
I'm Sean Gilligan. My day job is at Rivets. We do cybersecurity using trusted execution of blockchain. I've also been involved with the Omni Foundation for a number of years. And then my personal project is Consensus J, which is a library of Java tools for blockchains, RPC clients, things like that. I've done a little bit of work with Maincoin, and I like lots of projects, but the one I'm looking forward to spending a little more time with is what's a couple months old now, that is Handshake. And to me, decentralized web starts with the decentralized internet, starts with censorship resistance and resiliency.
Hello, my name is Ksenia Reyetska. I don't have a project now which I'm involved in, but I'm in blockchain since lots of changes into the space. And I really like Hasera project, and I believe that actually Hasera project and what those guys are doing is kind of future of decentralization now, because it is developing in steps. First of all, it was Bitcoin, and then they decided to develop something on the top, and they decided to develop Ethereum, and there grew up a lot of different stuff on the top of Ethereum and around and so on. And those guys decided to not be developing any new blockchains or tokens, and they decided to just take all those stuff which have other people developed and use it to solve real world business cases and use cases of other businesses which exist. So like banks, insurance companies, those guys who have some real use cases which they struggle with. And I think that that is the future of decentralization, because it will allow to use all those technologies and all those projects which lots of you are working now, or some other people have already developed, to solve some real world problems which really exist and which make other people and companies struggle.
Thank you very much. Richard, do you want to be our model of the Friday lunch?
Sure. Right. Okay. So, Brewster Kale, digital librarian here at the Internet Archive. I guess my favorite thing that's going on now, actually, I know it's really retro to say, is the cryptocurrencies, because I think it's gotten a lot of excitement in the whole decentralized. So I think we're really kind of riding that wave. And the more I know about banks, the more I like cryptocurrencies. And what decentralized means to me is no central points of control. I've been trying to get it down to sort of, if it's no central points of control, can we sort of make every part of the whole system interoperable and competitive, and so that it can evolve a whole lot faster?
Hi, my name is James. I'm a student. I have one project I'm working on right now. It's called Valoria. It's in progress, but I'm using Gun to build it. I think Gun's pretty cool. Yeah, that's about it.
Thank you.
My name is Matthias. My background is in engineering, but right now I'm a product manager as a consultant at the Blockchain University, where we teach different new developers to build on top of blockchain protocols. And I also have a podcast where I interview blockchain entrepreneurs in emerging markets. I'm originally from East Africa, Ethiopia. We don't have payment systems, especially international. So I'm working with one stablecoin company to bring international payments to Ethiopia, which did take a while. But,
would you like to give a quick lightning talk at the end?
Yeah.
You can think about it, right? Mark.
Hey guys, my name is Mark Patterson. I'm co-founder of a next generation, decentralized, generalized database protocol. Project in the space I think is super cool. I'm a big fan of Ravencoin. I think it's super grassroots, asset layer protocol. Just look into it, it's super cool. I think that's a great example of how you do a cryptocurrency similar to Bitcoin. And then what I think decentralization is, I think it's the idea of around like blockchain empowering the individual human minds. Like every single individual is capable and powerful of something incredible. And I think blockchain has the potential to empower every single human mind as a resource. I think that's important in terms of delivering it the next wave of value for mankind, is to empower every individual human being on a level that we haven't seen yet.
Thank you.
I'm Lauren Center. My tagline was DWeb Standard Speed. I worked on the web in the early days. My contributions included inventing the data colon URL ski and the 418 I'm a teapot Erica which actually had a serious purpose. It was to make fun of all of the people who were trying to assume HTTP to do appropriate things.
You'd be happy to know that's an active error code that we use at the Internet.
Yes, I've heard that people use it for testing as an error code we should never expect to see. This decentralized, I'm kind of with Bruce here. Decentralized means we're eliminating points of control. I'm really interested in the policy issues, about when you eliminate single points of control, you eliminate the possibility of censorship, which everyone hates censorship except for the few exceptions where they really want it. And, as soon as you produce a censorship-free web, you become an attractive nuisance. And so I'm interested in the policy points.
All right, thank you. And help me the best you can so we can get through everyone here. We're going to try to start talks in just a minute or two.
So I'm Anatoly and I work on Solana. My favorite project in the space, maybe not directly in the space, but it's the Rust compiler. I think it's an awesome group of people because the community project, so in and of itself, there's no single point of failure in that compiler, which is really cool. Decentralization to me is, I guess, one thing is privacy. I don't like that, like my smart thermostat knows my Google identity. It's weird. No need to stop me to change my temperature. But also as an engineer, it's really really a fun rabbit hole to think about building something that could outlast humanity. Maybe.
Hi, I'm Arthur. I'm a metadata specialist here at the Internet Archive. The decentralized web for me, and the reason why I started here is because I'm really interested in knowledge and data being able to outlive a DNS entry in a database. So, yeah.
Hi, I'm Amy Chen. I'm product manager for accessibility, user experience, and also accessibility in the user experience space for about 15 years. I have a little side project called historyledger.net. I'm looking for either a technical co-founder or perhaps a blockchain consulting company to help me build something. From a decentralized website, I'm looking for someone to solve the storage problem for me, whether that's IPFS, whatever Tim Berners-Lee is doing with Solid, or somebody to solve that problem for me, because we don't want to trust the Googles, the Amazons, and Microsofts of the world.
Thank you for being here.
Thanks.
Anyone else want to?
Yeah, and there's seats.
Yeah, please come on over and take a seat if you'd like. There's 3 up front.
If you want more seats, then
Yeah, please, if you haven't gone, please just shout out your...
Okay, I'm Saurabh. I'm from Volt. We're working on decentralized database services, encapsulating NoSQL and SQL and the kinds of things you get from Google and Amazon, AWS, into a decentralized cloud platform. My favorite project right now is also Handshake, which I'm hopeful will be limiting the central point of failure in a lot of censorship full systems.
Brian?
Yeah, so my name is Brian. I work with the Ethereum Foundation. I was excited to think about Filecoin and a thing called Altair, which is centralized mesh networking. Both of those are the few things I think actually are reasonable use cases of blockchain. I think they're overused a lot. But these two, it really makes sense to use them there. That really excites me.
Thank you.
I'm Rodney. I'm also with Woke. All this time I could not think of a favorite, so I'll skip that one. I think decentralization is, like was said before, like no single points of failure and readily available information for masses.
All right, who else?
Hi, I'm Matthew. I'm a software generalist at bigrinse.com. We do something that has nothing to do with decentralized web. My favorite project in space has to be IPFS. I think we've got to be able to copy bytes around before we start running programs on nodes and stuff. And yeah, decentralization, I don't want to have to trust other people's computers because I don't trust computers. So anything that makes it so I don't have to trust computers as much is great.
All right, I see 3 more people in view, so that's where we're gonna cut the line.
I'm Sam. I work in a project called Archon, and we do decentralized file storage actually. And so we're still in stealth, but we're coming out at the end of the month. So.
Darian, also with Archon. One thing I wanted to add on top of that is, pretty much blockchain agnostic. We're looking to bring file storage to most of the different public chains.
Scalable and high performance and decentralized.
Chad, no project. I do consulting at a normal company, but
thank you very much. Oh, yes.
I'm Suri. I work in computing infrastructure, DevOps, site reliability, and some projects I'm interested in are like Matrix and IPFS, and the decentralized. What it means to me is it's a distributed systems type architecture, but also it doesn't have like a single person or entity that kind of controls the whole thing. So like no single point of failure. And I think it's important to have if we want to have a free and open culture and free and open technology, I think this is kind of a critical piece of that.
Fantastic. Sorry. Yes.
Hi. My name's Mani, and I've just finished working with Consensus recently. So right now I'm actually not affiliated with the project, but the one that I would do a shout out for is Phone. We actually work with them. I was with the team doing Meetup and Sound, but I think what they're really doing around proof of location is really rare. And to me, decentralized web. A core part of it is obviously the privacy piece. I'm from a privacy law background, and actually that's like what is so striking about what we can do right now. And the data ownership side as well.
Thank you. Well, I want to really quickly thank Cole, who's helping us with some of our other friends here on the video and having organized the event. Brewster and Wendy for setting up so many of the logistics and products here, and for all of you for coming here and for helping this event be great.
Thank you,
Dan?
Matt, and thank you, Mac, for being MC tonight.
Dan, we skipped your intro, but I think that makes sense, given that you're going to be giving the first talk. Dan Finlay is the lead dev over at MetaMask, which is maybe best said as Ethereum decentralized apps in the browser. And maybe I can hand it off to you to give the first 10-minute talk, and we'll try to leave about 5 minutes for questions. And I will be the annoying guy in the front row with a stopwatch. I'll give you like the 5 minutes and then the 10 minutes, and then I'll annoyingly cut off and we can get to questions. Okay?
Cool, thanks a lot. Hi, I'm Dan, I'm from MetaMask. To answer the questions everybody else is answering, some of my favorite, I'm gonna take 2 favorite projects. I really like Maker's DAI. Having a stable cryptocurrency is foundational for all cryptocurrency. And then also, the Gnosis is safe. I think that having a generalized smart contracts for the individual to modularly compose their own permissions is like so key. It's fertile ground on which much can grow. And I'm gonna, I think, kind of build on that in my talk. So I'm gonna be, in just 10 minutes, describing MetaMask, my project, in a slightly different way than I usually have. I don't know, who here has used MetaMask before? Okay, yeah, we've got pretty good spread around at this point. So let me just describe it in kind of different terms that I think will help lay the ground for kind of where we're heading and potentially how some of your projects might think about MetaMask in the future and how you might want to integrate. So I'm going to describe MetaMask as a peer-to-peer capability manager. So if you want to look up Wikipedia for capability-based security, I made a QR code. I'm trying out QR codes as next. So a capability is something that it endows control of a function. It's communicable and unforgeable, and therefore it's delegatable, and so it has this kind of transitive. I think I like to describe it as a web of trust, but cryptographers will say that's a GPG thing. So, but it allows cool composition of decentralized trust networks. Oh yeah, and what do I describe as decentralized? I liked Brewster's definition. I would say decentralization is about minimizing the points where parties could become bottlenecks for opportunity, because I think value occurs when between individuals. So minimizing the number of people who can say when we create value between each other, that's decentralization to me. So let's talk about capabilities. So I've got some personal theories. I've got a little blog here. I'm not gonna justify these, but I think the capabilities aren't just a near perfect security model. I think that they're also key to social scalability, and I think they're today bottlenecked by entrenched institutions and usability of peer-to-peer. And we're kind of, at MetaMask, we're working on the usability. So in intermediated stuff, you've got a capability, but to get it as a consumer, you have to go through them. And in an intermediated site, that means that they have access to the corporation and they give that access to you and they can cut you off as they want. In intermediated knowledge, sure, the printing press was great, but only the publishers had it. That's why the internet is great, because, oh, we're all publishers and consumers, everyone can host a website, that's great, but everybody doesn't necessarily want to host their own website, and it turns out a lot of people just end up going to Facebook and then going through this whole thing in re-centralization. So the same thing kind of happens, a lot of Adam Smithian free market idealists would say, oh, well, everyone's a customer, free agent, you're moving around, but then in practice, you're using money that's given, it's printed and then allocated according to your government, and so however they deem fit for spending it. So what I'd like to do is I'd like to decentralize that. So let's think about the capabilities endowed by encryption now. There's three things, and they all require having a trusted computing environment, proving verifiable data, with the ability to conceal secrets, and the ability to prove authorship. Those are like the three big ones, but yeah, such a big field, right? So GPG has a degree of this where it's very flat and you can all sign each other, but it had some usability issues. That's my critique in a nutshell. And standard browser cryptography currently, it's got these great atomic units, but the browsers pick the certificate authorities, and the users just pick the browsers, and then the sites have to go to them, and so there's multiple bottlenecks, right? The browser vendor and the certificate authorities each can be these compromised things. Everybody has to go to them and get their approval. So MetaMask just wants to make crypto usable, and that's our goal. So here's our current login screen. We say, hey, this site, Peepit, it's an Ethereum-based Twitter equivalent. It's a lot of fun. It actually doesn't cost any Ether to use. They just checkpoint the tweets on there, so you can later prove them. And yeah, so it just looks like a login. So we want to make the capabilities of crypto as easy and familiar as possible. So our strategy is familiar interfaces. By default, to start, our MVP has been strong security. We make users back up seed phrases. Now, over time, we're talking about letting users opt into skipping amounts of that and then nagging them, or letting them opt into the security model that makes sense for them, because not everyone is ready for hiding some secrets and never losing them. Maybe you delegate it to a friend, maybe a group of friends, maybe a loved one, maybe an institution, but having the power to choose what your risk model is, I think is a nice convenience of having keys at the heart of your security model. And then we're going to add new capabilities that extend the platform. So capabilities that MetaMask shares with sites and applications today are, we inject an API into websites for people who haven't heard about it before. It's a browser extension. We let the website read from a trusted blockchain node. We let them ask to view the user's accounts. So this is a capability that it shares. We let them ask to receive signatures by the user's keys and suggest blockchain transactions, which besides, beyond what PGP made possible, now we've got financial capabilities, because every Ethereum transaction could be financial, it could be a vote, it could be who knows, it's Turing complete. It can be any operation and function. So it's very open-ended. So what are the capabilities that we have as a result of having this sandbox in the background of your browser with encryption keys that are backed up that we don't share yet? These are some things. So right now we've got, oh, I'm going fast. We have a persistent background process per user with a network connection. There's definitely some opportunities there. I think there's a few people here who are working on decentralized databases, and wouldn't it be cool if they had an easy way to plug into key management? Because honestly, as MetaMask developers, our hardest challenge is getting users to back up keys the first time, and that whole, so we're working on that song and dance. We've got a design researcher now dedicated to it. And if we can get users to manage keys one time, then we can hopefully extend those capabilities to every protocol that requires them. So then we've also got permissioned access to user recoverable keys, so kind of redundant there. But this is important because there's other kinds of crypto, not just Ethereum blockchain keys, but there's other. We've talked to companies doing ZK Starks, different kinds of side chains that require different kinds of cryptography. They just need a random seed that's recoverable to build and iterate. Storage access, of course, potentially having your own data, and then of course encryption. Sorry for taking so long to add basic encryption, but it's like a real elephant in the room. But once we have it, we'll have peer-to-peer, end-to-end encrypted websites and media. And what a great opportunity that is. We're very excited to add that. So, so those are things that I think you can look forward to seeing from MetaMask in the future, and based on where we are, just as a basically key holding container. Oh yeah, and then of course financial capabilities. So since we've got blockchain keys, that means now we've got these capabilities. We can enumerate them. They could be, it's limitless, right? The number of things. So you could delegate literally any capability that can be encoded on a blockchain. So that could be your, I mean, yeah, liquid democracy kind of comes for free if you build the platform right, where your vote is a capability, or your ability to spend money suddenly can be delegated. This allows for very liquid organizations, very dynamic trust models. And yeah, so if you want to play with MetaMask and you're a developer, we've got a great new doc site up, and you can check that out there. Otherwise, it's metamask.io, and yeah, that's the state of the world over at MetaMask. And thank you.
We can take a few minutes for questions. I would love to ask your first one, if you don't mind.
Sure.
What do you think is the biggest blocker preventing MetaMask from hitting a critical mass that you would like to see?
Okay, that's a good question. So I think there's a variety of things stopping. So for example, what I think we can look at, I think the video could hear you fine. Look at CryptoKitties last year. CryptoKitties had a viral moment. It was a sensational thing. I heard stories about like kids in the parking lot at McDonald's, like signing up, for the first time. Like there was this moment, and what it did is it hit the scaling limit of the blockchain, and then it dropped back down. So 100%, like the most important thing is it's the scalability of the blockchain. Now there is a lot of user experience that we can smooth out. We can make seed phrases nicer to back up all day long. But we've already seen that literally like you can reach the scalability of your blockchain, and then anything's popularity is going to bounce back, and now you'll have enthusiasts coming back. But you're going to lose that moment where like it could have been a thing, right? It could have been a contender. So yeah, that would be my basic answer.
Does anyone else have a question? And then maybe we can repeat the question.
Oh, sure, I'll repeat.
So I guess key management is one of the key things that it's like preventing people from like usability in terms of like getting your like non-technical grandma to get like into the space. Like I guess 2-3 years from now, I would imagine this is not the paradigm that people are going to be using. Do you see kind of like in the future a better way of perhaps like doing that, or like what do you think the future is going to look like in terms of key management?
Oh my God. Okay, so the question is, what will the future of key management look like? It's so important. I mean, all of these crypto visions hinge on it. Wow, I could really go off the deep end on this. I mean, it's not going to be a browser extension, right? Obviously, I actually think, I'll just leap. I'm going to skip a lot of logical steps. I think it'll eventually be that you have something like a blockchain client running at the BIOS of your operating system, and like a key manager, and it needs to be able to show you intelligible proposals of encryption functions onto the screen, probably bypassing the operating system, maybe hitting the display driver directly, something like that. Yeah, now what's nice about MetaMask is by being a browser extension, we can iterate quickly, we're JavaScript thing, and then when we're ready, we can drop down, we can become a system extension, and then when we're ready, we can become an operating system. But the point is, you just need a context that you can do your crypto, and if you can get a foothold of trustworthiness, then you're pretty good, and the rest is just optimizing for fears that hopefully won't happen. Yeah.
So the Internet Archive is trying to build the Internet Archive, but decentralized.
Yeah.
And we're crunching along on doing the public part of the Internet Archive, but there's a bunch that requires logging in. Do you have a mechanism for us to sort of smoothly migrate folks that have an Internet Archive account to being decentralized and then detach and stay in the decentralized world?
The question is, could the Internet Archive use MetaMask? Just in case my team members are watching. I think we might be able to arrange that. Yeah, actually. Yeah, we have a login system. So users of MetaMask are easily detectable by their browser, and there's a function that basically asks them to log in. They get to decide whether they want to show you an account. They get to show you, it's basically a public key, and then you can just use that as an identifier. If they have an account already, you can associate it in the background. If they don't have an account, you can use that as the only identifier. It's like a throwaway account that they are in possession of. So you can just say, like, we know them. You can give them a signature challenge if you require like high degrees of certainty that they hold that key, or you can just let people like kind of pseudonymously browse. You know, just depends on your requirements.
Anatoly, did you have a question?
Yeah, there was a security hack in a JavaScript library, I believe, that was like proxying keys. I forgot the name.
Yeah.
How do you guys are like sleep at night?
Okay. we have dreams of, we read team our own software a lot. So the question was, and I don't remember the name of it either because I'm more in the Ethereum space, but there was a Bitcoin browser-based wallet that suffered a dependency vulnerability. So one of the libraries they used, I think it was EventStream, got compromised. There was a contributor, a very helpful contributor, first just some linting improvements, you know, a colorful logger or whatever, and then before you know it, they're beaming private keys up to a central server. So we are naturally terrified of that kind of thing, and we're completely, you know, potentially prone to the same thing. So initially, we're in a similar situation. Now there's a couple things that we've done. First of all, we've reached out to the same maintainer who was, you know, very casual about giving out access. He's a friend of ours, so he gave us ownership of the modules that we depended on in case. So we're taking, you know, as much responsibility for our own code as possible. And then also, we're not ready to fully demo it or anything, but our founder, Aaron Davis-Kumavis online, is working on a browser-fied transform that basically sandboxes dependencies into assessed containers. So this would be a way of like absolutely limiting the scope of any impact. And I mean, that's just one. I mean, we're going through every option we have, but yeah, JavaScript, you can only get so secure, but yeah, you can do everything you can. And so we're trying to do everything we can. And we're pursuing more of an object capabilities architecture and containerizing and things like that.
Cool. All right, I think we're out of time for questions for now, but Anatoly, would you like to get set up? And then maybe, Mark, would you be willing to give a 5-minute lightning talk in the meantime while Anatoly is getting set up?
We can do that.
All right. Thank you so much.
Let me start time now.
Sure.
Hey guys, my name is Mark. I gave the introduction earlier. Working on a really cool piece of technology. We're calling it data blocks. It is a next generation, decentralized, generalized database protocol. So what we're seeing across all blockchain layer ones is this data problem. Everyone has a problem indexing data, querying data. They're having trouble getting access to blockchain data. Everyone's taking data off the blockchain, putting it into some sort of like a Postgres database or LevelDB or any number of different databases, and then querying that and having that indexing, then querying it, and it defeats the whole purpose of blockchain. By centralizing any kind of decentralized data, you kind of, like, what's the point of blockchain at all? It's really slow, it doesn't scale with decentralization. So what we see as a future that needs to happen is, why don't we atomize the database? You have many different kinds of data models with different databases. What if you could have a protocol, whether it's relational, whether it's key value store, whether it's document-oriented or graph-oriented, whether you have a database protocol that does all your data models for you. You don't have to worry about wrangling with everything. You don't have to worry about, you know, how do I need to define my data models ahead of time, get them all to connect, and have all these back-end engineers taking care of everything. What if you can analyze all that? A network dynamically shapes data depending on a query. And what if the query becomes the master of these applications? That a database runs inside an application. It can run on end user devices. It can run anywhere where there's compute. It can run on a mobile device, an IoT device. It's not going to be on some central server where you're always doing a query. There's a back and forth, like requests, and you get the data. What if you have all the data with you in your mobile device? Your queries are all done locally. Everything's local. And it can dynamically handle the data so that when you do a query, the network dynamically shards this data. We're calling it query-centric sharding, and that your queries define how the data is sharded and resharded and joined to give you the data that you need, depending on your query constraints. So you have applications from a database perspective that are truly decentralized, and that they have the data with them, it's highly compressed, and they can compute and do everything locally, so it's way faster. You'll have applications in the future that are going to be decentralized, that are going to be way faster than anything that's centralized. Because you'll have the data with you, you'll do everything locally in the application, it'll feel like a native application. Today, like if you use, let's talk about like a marketplace in a centralized instance. You do it anytime you change a constraint on this marketplace, any range, or you want to change a value on how much a car is. It's really slow. I mean, it's not that slow. It feels fast. But in a decentralized world, we can have marketplaces and application experiences that you run in the browser on your mobile device that will feel like a native application. Like we're going to see decentralized applications in the future that are going to feel like, wow, this is running on my device. This isn't the internet. But I guess if we want to get deep down the rabbit hole real quick, I mean, I can talk about this forever, but I like talking about rabbit hole stuff. Imagine a future where we're walking around with brain-machine interface technology, stuff like Elon Musk is doing with Neuralink. I don't know if that's stuff that you guys think about. And do you guys think about a far, far future where blockchain is going to be this sort of enabler of having us connected to the internet and sharing experiences with each other, and that needs to be personal, it needs to be decentralized, it needs to be incredibly secure, and no one should know what you're querying, no one should know what data is going on inside you. Everyone talks about Google and AI knowing everything that's going on in our heads and our lives. We should have technologies that empower us and technologies that give us our privacy and no one controls and no one can see what's going on and what we're doing in our lives. And we should have databases that reflect that. We should have databases that can run anywhere, can quickly, like, what was I going with that? Anyway, yeah, but we're building a network where we don't see a need for anybody to build their own databases, their own backends. We think you can just use a network instead, drop in a few lines of code, and you can have a network that does all your database needs for you. That's incredibly fast, it beats centralized technologies, and yeah, I mean.
Do I need to last minute for questions?
For questions, yes, exactly. So
Anyone
any
have
questions?
Questions, Mark?
Yeah. No questions? Cool.
Thanks.
All right, thanks guys.
Next we have Anatoly Yakovenko from Solana, who's going to talk about proof of history and blockchains that scale.
Hey guys, so I'm Anatoly, co-founder and CEO of Solana, blockchain for scale. So our secret sauce, which is open source in Apache 2.0, so not so secret, is a source of time that works before consensus. So verifiable delay functions, there's a bunch of awesome folks that are doing research on this. You guys can check out our PDF research. But effectively, these are functions that are slow to generate, and not just slow, but impossibly to parallelize. So you can't really speed them up by throwing more silicon at it. But verification is fast and possibly parallelizable. And the goal of this research is to kind of build stuff that is polylog verification, meaning that it's algorithmically a lot faster to verify than generate. So if you guys want to check out these papers. But for us, what we have is proof of history, and this is a very, very dumb VDF. I would even call it a delay function that can be verified, not so much a VDF. So our VDF, if you want to call it that, is a SHA-256 that loops over itself. So SHA-256 is a cryptographic hash function. It has this property called pre-image resistance. So if you take its output and use it as the next input, this process, because of this property, becomes non-parallelizable. You can't really predict any of the outputs in the future. So if you take this thing that runs over and over and over again on a single CPU core, and you sample this process, you get this data structure, samples, that really represents time passing somewhere. And that's it. So given this data structure, you can kind of look at it and be like, okay, time passed somewhere between count 0 and 5 trillion. So why is that interesting? Is for us, you can take this data structure and then verify it on a GPU. So this is not polylog by any means, but on a desktop GPU, you can verify 1/2 and 1/4 millisecond, because this is very easy to verify on GPUs, because you can use SMD lanes, and for every slice, you can start at the start and run at the end on a different SMD lane. And NVIDIA is doubling CUDA cores every 2 years, so in a way it is, it does get faster than linear time every 2 years. Not really. So why is this useful? Is imagine taking a photo of yourself with the New York Times holding next to you and publishing that photo in the next issue. So in a way, you've proved that you exist after that paper was, the paper you took next, you were holding, you existed after that paper was published. But also you existed before the next issue was published. So we can do the same thing with this process. So our SHA-256 thing is running over and over again. And if you take the hash that it's generating, this 256-bit value, it's totally random and unpredictable. And you take this value and you take a message, and then you stick the message in this value and append it to the same process. This modifies this process and all the subsequent hashes in an unpredictable way. So now you have a guarantee that you existed sometimes before this modification occurred and sometime after the thing that you appended. So now you kind of took a picture with this cryptographic New York Times thing, right? So what's cool about this is now when you look at this data structure, you have a bunch of events, and you can kind of get a relative sense of order of these events and a relative timing between events. So if you were to trust this as a source of time, you get this like kind of concrete representation of all the events that occurred in this ledger, if you want to call it that. And rewriting this ledger would require you to start at the end and generate as much of this data again. So effectively rewriting any of the order in the middle in this data structure, present a data structure that is just as big, would require total rewrite. So it kind of has this nice property. But you know, we have 2 to the 256 valid clocks at any point, but they can all tell time, right? And that time is actually not the bits that it's generating, it's the actual count. The actual counter that keeps rolling is this kind of like level of a water clock. So as this cryptographic data structure keeps growing, the level keeps rising. And this level is the important part. That is actually our source of time. So given that this is our source of time, how do we actually agree on a clock? This is the really hard problem. So now we're trying to figure out consensus. So we don't really want to rely on a single POH node, but for stuff like Internet Archive, you can imagine even running this thing in a trusted centralized setup and just keep submitting hashes to it and timestamping everything in the world. Because the end result is still just as good as if it was decentralized. But for us, for our particular use case, we really don't want to rely on any single point of failure. So, you know, if something fails, how do we actually start appending to it again? You have a bunch of nodes that all want to append at the same time. So I have 5 minutes, so I'm gonna move a little faster maybe. So what's cool is we do have time, and time can be used as order. So because we can look at our structure, our data structure, and look back in time and figure out the relative time and order of events, we have this snapshot of a view of the network as it's participating in the structure. And given that snapshot and all the nodes, we can then order them to append at any particular height. So we have now, instead of trying to figure out who's going to append next, we've simply said, okay, everyone that's appended before, you now have a fixed, very predictable round-robin order that's derived from previous history. And you can append to it at your specific height. So now all we need to do is deal with some failures. There's lots of failures, but what's cool is when you do have a failure, it's not really a failure that's observed, it's a failure that's proposed. So anyone in the future that wants to show that a failure occurred in the network is simply generate this hash, this continuous hash function to the height which allows them to propose. And at that height, you know, they have this, again, they've derived a new data structure, a new fork, that really shows that these other nodes, you know, C3000 and B2000, they weren't in the network. But since I generated this data structure, I can kind of demonstrate that they failed. So that is like a really cool property, because what that means is that in a decentralized network, again, we're not relying on success of transmission. I can simply generate enough data locally to where I can start transmitting. So now all we need to do is deal with forks, partitions, and potentially faster ASICs. And I have 5 minutes to describe that. So how we deal with that is voting. So what's interesting is that for us, voting indicates a commitment to consistency, as in cap theory consistency. So vote contains a lockout, and a lockout is the number of hashes that somebody has to generate before I can break my consistency. So that means that I actually have to be unavailable for X amount of time before I can break my commitment to this particular fork. And each vote doubles the lockout of any previous votes. So this exponential growth is kind of actually what protects us from all the other problems. So if you kind of look at it very simply, some validator is voting on forks every time it votes. Its previous lockouts keep doubling, so these are growing at an exponential rate, while the actual history is growing at a linear rate. So then what happens is somebody proposes, I don't like this history, so I'm going to give you a new one. No enough, always messing with the network. So what happens there is because these votes have a lockout that expires around 6,000, when NodeF proposes 7,000 that doesn't contain them, they have expired, so we can now clear those votes, and we can simply vote. We now have the option to vote on this new branch, in this new historical record. How much time do I have? 1 minute, okay. I was planning for 15 minutes, but effectively, that is kind of the gist of the algorithm. So when you're committing to a particular branch, a particular fork in the network, every time you commit, you're doubling all your previous commitments. So this exponential growth allows you to continuously kind of add more commitment to consistency. But if the network screws up, if like in the future you get a bunch of failures and all of a sudden you can't really come to agreement, these earlier commitments that you made have a lower lockout and they start expiring. And this allows you to roll back and kind of continue at a different point. And that whole system allows this network to continuously generate the source of time without actually relying on any single source or any single generator. And once you have that, you kind of can start ordering events and you can build your state machine on top of this and you have a whole blockchain. And the rest is really da 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 da. Cool, so check out our project, it's on Discord. We have a Discord, everything's on GitHub, it's Apache 2.0, so steal our code, fix our bugs, it's a must. Please.
Yeah, the problem with decentralized time is a fascinating one. I wish you had more time to go over it. Quick questions that I have. One is, could this work for sort of the Ethereum version of smart contracts where they are their own account? If the accounts aren't necessarily living on a machine that could be running this SHA function, as in like the smart contracts themselves can send transactions?
This source of time is used by the actual nodes in the network to kind of come to agreement. It's not really used by the contracts themselves. And because we're entering data into the SHA-256 thing, that output becomes biasable, so it's unadvised to use as anything meaningful.
So that is to say that you do support smart contracts?
Yeah, our blockchain supports smart contracts.
Cool.
It's similar to Ethereum account-based model, so there's a state transition function. The front end is LLVM based. We're trying to get Rust to work, but C++ work right now.
And other real quick question, like in transaction fees?
Yeah, we're transaction fee based. Go ahead.
So in terms of voting, do you force every validator node to vote on in terms of failures and kind of the canonical blocks?
So,
Can you repeat the question?
in terms of voting, do we force every validator to vote? Do you mean do we have delegation? That kind of thing? Or?
I guess is every node just expected to kind of have their viewpoint of this is the canonical height of this block?
So the cool thing is about this is that from a distributed system design is that I can send you this data structure in an SSD card with a carrier pigeon, and you can start looking backwards in this data structure, and you get all these events, all these messages, validation messages, and you build a view of the network that is based on this data structure, and that view is identified uniquely by this last hash that was generated. And if we all get lucky and everyone gets the same SSD card and then the carrier pigeon gets shut down, we can optimistically vote and observe those votes in the future. So as long as that part is true, as long as we can optimistically do this and observe in the future, this is where the speed up comes from. But there isn't there's no requirement on the number of nodes or the number of voters. You can kind of slap your own voting scheme on top of this. Ours is fairly rudimentary proof of stake. You get some stake, that stake is your weighted vote. Any questions?
All right.
Cool, awesome.
So we're going to have Matthias give about 3 to 4 minutes of lightning talk, followed by a minute of questions. And then Mark, would you mind setting up in the meantime? And as we're doing that, is there anyone else who would like to give a short lightning talk after Mark? All right, we're going to keep it to like 2 to 3 minutes, and you can do that as Mr. is coming up to close this out.
Yes.
All right. Matthias?
He's
You wanna come on up?
There's still 2 seats. You're getting tired.
Okay, thank you for giving me this chance. My name is Matthias, and I'll just randomly select it, so I was not ready for this, but I'll try my best. So, yeah, I'm originally from Ethiopia, which is in East Africa, and we, for example, in different third world countries, international payment is really hard. So, for example, we don't have any kind of international payment. That means people can't buy anything digital, over the internet. So, what interested me that will solve this problem is, I believe, if we have like a real, stable coin that is, fixed dollar amount, and when different companies start accepting stable coins, I believe it will solve a lot of problems in third world countries. So for this reason, I recently launched a podcast where I interview blockchain entrepreneurs in emerging markets. So the problem they solve is way different than what's happening here, because we have different issues. And from my understanding, data privacy is not one of them yet. Because there are so many things that has to be solved. Yeah, and one of the other thing is a lot of people are also unbanked. So if you go to Ethiopia, there will be probably like 65% of the people are not banked, and most of them live in rural areas, so which is really difficult. One example I really liked, which is not a blockchain-based system, was I don't know if you guys heard about M-Pesa, which is a Kenyan mobile payment system that even grandmoms can use it. So what I can imagine is if we have a decentralized blockchain-based system, something like that, that can be used in emerging markets, it can lift a lot of unbanked people. And another problem I see is since people don't have this payment system, they have to go through friends. For example, I might help my friends to get access to any kind of payment system here in the States. But what happens is there are a lot of also companies who provide this kind of service as a middleman, but they take like 20 to 50% cut of what people make. So imagine you have a website and you want to have access account, but you live in an area where there is no international payment. So when you go through the third-party companies, you have to give them 20, 30, 40, even 50% of the share. So this is real problem. So I hope when we have stable coins that are really stable, they will solve this problem. Yeah, I think that's what I have.
Wonderful. Any
Do
questions?
you have any questions?
I got a quick question. What exactly is the connection with the stablecoin and unbanked and third, underserved countries? What is the connection?
Okay. Yeah. So the question is, what is the relationship between stablecoins and unbanked people, right? So from my understanding, right now a lot of people don't have a trust in cryptocurrencies because of the price fluctuation. So if you tell people, hey, buy this cryptocurrency and use it, they know that the value might go up or down. So it's really it's really hard to be used in a daily day-to-day activities. So when it comes to unbanked people, if they get access to stable coins without being like really resistant. They can use it on a day-to-day basis.
Quick follow-up. So what's the problem with the existing stablecoins that they're not doing?
I think it's maybe like the adoption. Not a lot of people know about it. Even like my friends I know, even like in the States, not a lot of people are also informed about stable coins yet. They know about cryptocurrencies, but not a lot of people know stable coins yet. All right, thank you.
Thank you. Thanks very much, Andreas. Mark, thanks for your patience. Everyone, Mark Nadal is the CEO of Gun, and he's going to be talking about decentralized database management systems for P2P applications.
Hello everyone, I'm Mark, and this talk is going to be a show, not tell, and I'm going to actually dig into doing some code and engineering. But I want to start with the top level view and actually say huge thanks to Brewster for doing Alexa site rankings way back in the day that he sold to Amazon. And I think this should be all of our goals of tackling. There's a Google, a YouTube, a Facebook, a Wikipedia, and a Reddit. We need, you don't see banking websites, to be the contrarian, I guess. You don't see banking websites as the top websites in the world. So we need decentralized replacements for Google, YouTube, Facebook, and Wikipedia. Thankfully, Internet Archive has actually, I think, already done 2 of those, which would be Wikipedia and Google. But there also exists decentralized versions of YouTube. So here's an example of it called DTube. You can go and click on videos. They're running Gun on it. And there is a decentralized version of Reddit right over here. You can go to notabug.io, which is a reference to an Aaron Swartz quote. So here's Gun running in action. I can just scroll through the decentralized Reddit homepage, and Gun is just pulling this from other browsers, other super peers, other IPv6 peers, and it's fast. Just keep on scrolling and scrolling, and it catches up. So we need to take this seriously because if you check out the rankings on this stuff, like DTube has about 1 million monthly uniques on it. And if you look at the Alexa rankings on Notabug, right, like in the United States, it's top 13,000 website in the world. Same thing with DTube, it's like top 16,000 website in the world. Oh, sorry, United States, not globally. But they're pretty high up on the global marker. This is exciting, right? So that is 3 of the 5 sites. Internet Archive is also has a decentralized component on top of Gun. DTube is running on top of Gun as well, and peer-to-peer Reddit. So we have a Wikipedia, a Reddit, a YouTube, and we just need to keep on getting user adoption. Now, here's the tricky thing though. When you actually start running these sites and browsers are relaying data, not servers, you can get into really sticky situations because we have historically developed assuming that we have a master-slave system, that when I ask for data, I pull it from Google servers. So I'm gonna run a demo here. Let me see if I can put the mic down. Oh, okay. Start. So if we're building a regular old app, this is just my demo app, I might be like, oh, I want to create a to-do list. Hello world, okay? So it syncs in real time. But what happens when things go wrong? So right now I'm going to cut the connection between these 2 peers. I do happen to have a local relay peer, and I don't have WebRTC turned on in these 2 browsers. We do have WebRTC working, but I'm intentionally turning that off to show what these edge cases would be. So we've crashed, quote, the relay peer, and we're going to make conflicting updates while both of these browser tabs are, quote, offline. So A over here, and on this side, B. Okay, let me refresh, and it's going to be pulling from the... This is a hairy situation that we're in, because I'm going to, on this guy, delete all the data that is associated with it. So the only copies of the data that we have are fully peer-to-peer in the browsers right now. So when I turn the system back on and I restart, I want both of the browsers to converge to the exact same thing. Boom, they do. Okay, this is important because there was no server or master that we're pulling the data from. So most of the time that when we build and design apps, we are oftentimes assuming that the tests in our apps are pulling from a source authority. Now, when we're in the DWeb, we're pulling from many different places, many different machines around the world. How are you going to test that? Well, we spent the last 4 years and we built a distributed testing system. So I'm going to now show this exact same test that I did by hand that I have to do across 2 different browsers, 2 different machines, and I'm going to fully automate it. And this will let us, everybody who's building the decentralized web, okay, create automated tests that can spawn across many different machines around the world. It's already working. And then we can actually have those machines act like humans on these applications and verify that our YouTube, our Facebook, our Google is behaving the way that we expect it to. So, okay. I'm going to clear out the data. We launch this. It's compatible with Mocha for any developers, JavaScript developers who use Mocha. It's compatible with pretty much Jasmine and a bunch of other ones. So it's very engineering focused. It's called Panic, and we're going to run what I call a Holy Grail test. It's going to say, hey, please open to 2 browsers. So I open this up here, and then I refresh over here, and it is going to run through and simulate the test that I just did, except for fully dynamically. So let's just give it a second. It's going to crash. It's going to restart both browsers. It's going to wipe the data from the one before, and you get the conflicting updates, and we see that the last line on both is Bob. Woo! All 21 tests passing. Okay? And if you guys knew my IP address, you guys could all just hit in the subnet on your computer and spin up this test as well and run it with it. Or this could be different machines anywhere in the world as long as you have access to the coordinating Panic server that orchestrates the panic to cause the system. Now, the cool thing is, that, okay, that's checking whether our decentralized application, or DApp, is behaving correctly. But what if we want to test if the decentralized application can scale correctly? Well, we can take this exact same code, and we can just modify the test, like this one over here. I'm going to not run the Holy Grail test. And this is a very stupid, it's hardly a scaling test at all, but it runs on just the one device. We're going to call a load test. And actually, if you pull up the source code, the load test here is fully documented, and it's, I think, less than 100 lines of code to write a fully decentralized test system that also then scales, or I should say, to test whether your system is scaling or not. So let's run it. Okay, it's going to say open across 4 different browsers. Let me hit refresh on this one, hit refresh on this one. I'm going to open up a new one over here, and then I'm going to throw in, and again, this could be other machines. It doesn't have to be just on my laptop. All right, so now we have 4 devices open, and oh, it's already running. Let me shrink that down so you can see what's happening. And actually, it looks like, there we go, it's just kicking in. So you see on the top right, sorry, the text, let me increase the text. The top right, you can see we're going to save 6,000 records across these 4 different peers. Each one does whatever 6,000 divided by 4 is. And it's just spanning the whole network with all these different peers. And every single peer is going to deterministically verify, as all these messages are getting sent in real time right now, that every other message has been received by all the other peers in the network. So Panic is really easy to get started with. We use it for like in the last 4 years of us building out a decentralized database that is now powering DTube and Not-A-Bug and decentralized version of the Internet Archive. It's very, oh look, all 6,000 records have been saved and the test pass. So it's very, very important, right, that this gives us the ability to know that our systems are reliable. And that is going to be so important for user adoption as we scale up from the current millions of users to tens of millions of users and ideally into billions of users. So.
All right. Yes.
Might be a little bit in the weeds, but you have like Selenium integration for popping the browsers up. Like I want to go across my whole, cluster of Selenium nodes and
Yeah, I think the guy who built Panic Server for me, he was on my team. So it also had a Selenium integration or something, or Night Watcher or something. I'm pretty sure he was running it with Selenium. I just don't know how Selenium works. So yes, it should be possible. As to whether it's working right now or not, I don't know, but yes.
Well, Bruce, would you like to set up? Yes, another question?
And just last thing, if you go to gun.eco, ECO, that's our website, and you can click on the GitHub link to find more of the gun stuff and the panic tests.
So I guess like two quick questions. One is in terms of like networking transfer protocol, is that do you like is Go agnostic, or are you like opinionated and using kind of like TCP, UDP, some sort of protocol in particular? Or?
So the question is Gun protocol agnostic for the transport layer? The answer is yes. We built it works across WebRTC, WebSockets. I used to have a JSON long polling HTTP one, but it didn't have the performance we wanted, so we just kind of dropped supporting it. And our network stack, Gun is kind of split into 7 or 8 different components, and the piece that handles network transportation and abstracts that across all different TCP, WebRTC is called DAM, for Daisy Chain Ad Hoc Mesh Network. And it already, so I know that like IPFS has lib P2P, and libp2p, I think, still has problems with flooding the entire network. DAM, and also Secure Scuttlebutt has a sparse interval tree for this as well, but both Secure Scuttlebutt and ours, DAM, already have the optimizations for doing network routing in a peer-to-peer environment. And then we're going to introduce even more better optimizations with a thing called Axe. But yes, that's there, and I'm very biased towards ours, which is called DAM, because it's running in production already with a lot of these sites.
Also, for something like DTube, I know a lot of kind of like peer-to-peer video streaming services kind of have to use like transcoders. Is that like, does DTube just kind of like do peer-to-peer just file transfer like a video file, or does it also like incorporate video transcoding into it?
So transcoding the browser kind of sucks. So in DTube's case specifically, they do upload it to a one of many different peers. It's not centralized because you can run your own, and then do transcoding on GPUs on those super peers. Now, this is actually an important issue that I probably should have mentioned in that to-do app that I was showing you manually, how to go into this failure mode. Every single time I typed, it was syncing in real time. Gun can do mutable decentralized data. A lot of these other systems are only immutable. So you can do immutable on top of Gun as well, but you can also change things in Gun. And when it comes to transcoding videos, this turns out to be really, really, really important because in immutable systems, right, like you have the video file, and then you have a bunch of these different transcoded versions, and they all have different hashes, so now the hash doesn't necessarily reference the content you're trying to get in general. And so I think it's actually very, very important that hopefully in the future we'll be able to get like really good GPU processing power in the browser that we can do transcoding in the browser, but actually that's a long ways out, because then we can use mutable data structures to actually dynamically at the network layer optimize, like YouTube does, based on the other peer that we're streaming it out to, what resolution we should be sending, and we can dynamically change that in real time as we're streaming it. You cannot do that with all of these other immutable, decentralized, blockchain stuff, because you get locked into the hash. So I'm glad you brought that up.
All right. We might take some questions later. Thank you so much, Mark, for that really amazing demo. Last but not least, and then we'll try to make a little bit more time for a few lightning talks if anyone wants to come up, is Bruce Kale, the founder and digital librarian of the Internet Archive, here to tell us about DWeb.archive.org and some of the other exciting advancements at the Internet Archive.
Thank you. So, the Internet Archive, we've been trying to get this DWeb thing going, and so we're doing a couple different approaches to try to help build the DWeb. One is these sorts of gatherings, and we're going to be doing the Decentralized Web Camp this summer, where Wendy Hanamura is out basically visiting a few different places that we can go and sort of hang out together for 4 or 5 days and just have fun in the woods as sort of a, I don't know. Okay, so that's one. And also these these sorts of things. The other thing is to try to eat our own dog food by going and seeing, can we make the Internet Archive but decentralized? Right? So just as Mark said, can we make Google but decentralized? Can we make Reddit decentralized? Can we make the Internet Archive but decentralized? It turns out it's hard. There's this guy named Mitra, who's right now in Australia. He's LinkedIn here somewhere or another, getting more work done because he's far away. And I'm going to try to demonstrate a couple of things. What I've shown before, and actually, Mark, where were you last October in terms of load testing? Because I completely blew this my demo in October. I had everybody together, and it's like, okay, this is all going to work. And I said, okay, everybody, take out your phones and go to this website. And then I tried to, and it didn't work. Okay, so yeah, it was not a good moment for me. So going and doing load testing is a good thing. But here's the Internet Archive website with the web console sort of showing on the bottom of Firefox, and shows just how much awesome JavaScript is running, which is nothing. If you take this and go DWeb.archive.org, which I think is a great subtitle for a prepend for websites that are decentralized, then all sorts of things fire up. So HTTP, YJS, IPFS, WebTorrent, and Gun are all just firing up, lots of just JavaScript going bananas here. And basically, you have a simplified form of the Internet Archive from a reader point of view. So it's the public stuff on the Internet Archive, and it's all sort of coming in. IPFS is going and pulling in some of these things, and the like. So I think it's kind of cool that we're able to go and make the Internet Archive, but decentralized kind of work. And so yeah, we can go to Prelinger archives, and I showed this last time, so I'm just going to quickly blip over this. But anyway, lots of JavaScript, awesome. Okay, now what Mitra's trying to do as part of this, and working with lots of folks in this room and others to try to make this all come true, is to try to make the Internet Archive work where the internet sucks. And the internet might suck because it's either expensive, or it's really slow, or it's censored. Can we make the Internet Archive work in those sucky situations? And there's this sort of peer-to-peer from the JavaScript within your browser, but it's extremely limited about how to go and put data down someplace. It's not been very easy. You open a new tab, everything's brand new again. The browser isn't well designed yet for the decentralized web. So we're still working away on this, but we are also trying something else, and I'm going to demo this very first time right now, and pray for it to work. That worked last month. This is what, okay. So now what we're going to try to do is take parts of the Internet Archive and go and say, I want to crawl this whole collection, and I want to pull it down and put it on my machine, and maintain that, and then that would be served through IPFS, WebTorrent, and every ever new HTTP, everything, all different protocols, and put that out again to anybody that wants to have access to it. So you might want to be a super node of just this part of the Internet Archive. So we're going to crawl the Internet Archive, put it here. Then I'm going to show how a browser talking through a caching client on its own will basically go and leverage this either directly if it's in its own cache or out to the web. Okay, so that's the idea here. We're gonna crawl a bunch of the Prelinger archive, which is a bunch of movies. Oh, come on, work. Okay, here it is. Okay, hello, wonderful person. It's starting up Gun, which is, you always know that because it's hello, wonderful person. And it is basically bringing down a whole pile of files, actually really using HTTP. And it just did all of that. So that's kind of cool, but not also very important. Then I'm going to start up a server that is going to be my proxy that my web browser uses to go and use it. Because we've got people that want to go and take away terabytes, if not petabytes of materials. Okay, so here it comes. Here's Gun starting up again. And it sort of starts up this whole little stack. And now, if this works, I'm going to go to a
proxy link into this world. Where's my DWeb? There it is. Boop, boop, boop. So instead of going, starts up, it's going to a local host, and here's, let's see if it works. Chunk. Ta-da! And, and the cool thing would be, if this, see if it goes, is, yay! Okay, here's the moment of when everything fails. All right, so here I am, I'm now offline. Can I actually go and do a refresh? Come on, work. And no, hey, guns up. All right, okay, all sorts of things starting to fire up. Okay, hey! All right, so okay, we've got sort of a dopey little Internet Archive website coming in for your pleasure, completely offline, which I think is kind of cool. Here is Health, Your Posture. Now, this is a really important movie to see, and let's see if we can. I wanted to actually show it loading now. Do I completely lose? No. All right, here it goes. Did it really just load that fast? I guess so. All right, and Health, Your Posture. If we had audio, you'd be hearing about how you should be sitting up straighter right now. So just please, just a moment, just sit up a little bit straighter, and you have been at the Internet Archive learning your lessons from here. So thank you very much.
Yeah. Maybe a rhetorical question, but what parts of the internet do you think are most susceptible to be like, for like internet extinction? I guess what sites do you think are kind of the like most susceptible to being like lost in general?
The really important one, the person that becomes really important 10 years from now, right? That's probably right now we're getting a lot of use of the Wayback Machine of people, what they said 10 years before when they were just in a political blogger environment, and now they're part of the government. And I think that's probably happening in lots of different places. And so we have to be very wide about sort of what we think we should be going and archiving and using as many signals as possible to do it. And we're trying to do as best we can. Yeah.
So how do you guys decide what to index and what not to index? Like how soon is it like based on clicks? Is it based on like activity? How do you guys decide? Do you index everything, the entire internet itself?
And collecting it in the World Wide Web?
Yeah.
So when we crawl the web,
yeah.
How do we do it? Or sort of how do we know what we should do?
Yeah.
So we have some, sort of dumb bots that have sort of basic protocols that they do, like I'm news, and they just and they do this. And there's sort of these big sweeps. There's ones that use the Twitter the feed as signals to go and get those. And there are 1,000 librarians and 600 organizations that have set up scripts to basically go and say, get these at this depth, at these intervals, because this is very important for the elections in my country, or my organization has these sorts of things. So we're trying to use a lot of different signals and a lot of different people to participate to build the Wayback Machines collection. So it really is a crowd. And then there's Save Page Now. So Save Page Now is if you go to web.archive.org/save/URL, we save it right then. And people do a lot, and a lot of robots do too. It's about 80 a second. And so and it's a lot of people basically going to say, now, get this. So, I don't know, the famous Ukrainian blogger of the guy going and bragging about shooting down this airplane. And oops, it's full of a bunch of Dutch scientists. Oops, I didn't do that. But already 5 people had said, Save Page Now! and so that's another sort of crowdsourced mechanism of getting the...
Well, if I went made a website right now, and now you didn't link it anywhere, no one had the link to it in there, but had a URL, would it crawl that? What's the...
No, we'd have to know about it somehow. Right?
Okay, what's the threshold for what websites you crawl?
It's Save Page Now. There are these different signals, and we're trying. So probably the hardest one is the social media, because they don't like to be crawled. And YouTube just changes things all the time, bad citizens. Yeah,
So I have a question, I guess you created Waze.
yes.
And there was Gopher,
Wow.
and all those other systems.
Oh,
So,
gosh, oh, yes.
do you see a parallel with?
Waze, but not that one, right? I did Alexa, but not that one. Story of my life.
There's like you have all this hodgepodge of technologies, and there's, you know, like, I must have seen like 100 different frameworks that all say the same thing. So how do you think that it's gonna get narrowed down? Because
In the DWeb
yeah,
space?
yeah.
I love this phase. And the thing I really love about this phase is I love the dreamers. I love the people that have a sort of, this is going to help me on this thing I've always wanted to do. Right? And the technology is going to let us down. It does every time. Television. The dreams of television. The dreams of the telephone were really, it's completely amazing. The dreams of the World Wide Web. And it's like, you know, at the end of the day. But it's the dreams that are important, because if we go and make sure we listen to those, we should then build the next technologies to incorporate more of them, right? The important parts are the dreams. The technology always sucks. So yes, we're going to have some consolidation. It's going to become some weird ass thing. But let's keep it going. I'm hoping that we can lock this one open. I hope we can keep the DWeb alive for longer than, say, the evolution of the web. The web got locked into a whole standards organizations, you know, Larry Messinter knows better than anybody just how dreadful those things are. And it bogged down. We didn't get innovation at any rapid pace. And if we can go and put JavaScript layers in here that can be rapidly swapped out and make it so that it's more user controlled, I think we could actually have more dreams built into this next generation than we even had built into the last.
Where are we? Like, how soon before, like, you know, Microsoft?
We are before the beginning, right? Look at us, right? We're still trying to get this stuff to work. Like, CryptoKitties is the best we have to offer. It's like, whoops, okay, we're still early on. But I love that, right? We're so far so good. I mean, it's really got smart people. There's people that are in it for a lot of the right reasons. Yeah, there's the greed thing. Yeah, that's a bunch of that. But there's also people that are really interested in solving some of the problems that we're seeing in society. So I think we're going to see an interesting evolution here if we do it right. And one of the big reasons for the Internet Archive, which is .org at the end of its email address, is to try to keep this thing kind of going towards a northern light that is worth having achieved at the end of the day. Otherwise, just a bunch of people are going to get rich. They'll be on the cover of magazines, and who gives a shit? Right? That will be a failure if we do that. Let's do something much more than that this time. Thank you.
Zane, do you want to give a short 34-minute?
Follow that.
Is there anyone else who wants to volunteer a tech talk?
I can do it.
All right. All right. And I guess the mic before we miss out.
So I'm walking down the street on this bright, sunny day, almost blinded by the light. The wind is whipping. My scarf is blowing in the breeze behind me. I can barely feel my fingers. And to the left of me, there's a wall as far as the eye can see of snow piled up higher than my head. I grew up in Texas. This is extraordinary circumstances for me. I dip inside off the promenade into the warm recesses of Crypto HQ, where I was introduced to this European Union commissioner. And he just had question for me after question after question about blockchain. How does it work? And he kept circling back to, could this be the answer for GDPR? It was the World Economic Forum in Davos, Switzerland this past year. And it really got me thinking about, if you're anything like me, you believe in the future of decentralized applications. But if we think about the value of applications today, every time you like a page, you're generating valuable data for Facebook, Google, Amazon, pick your poison. And as we move towards a world of decentralized applications, it kind of forces the question on us, where does the value of that data go? And so, at Dispatch, we are working on cryptographic tools to enable decentralized data analytics. It's a two-network system with a ledger and decentralized data network built for decentralized applications that want to enable these decentralized data analytics so businesses and researchers can query all of our data that we're still in control of and get back provably correct answers without ever having seen or touched our underlying data. So, if you're a distributed application developer and that's something that's interesting to you, I'd love to talk to you more about it. Short and sweet.
Questions?
What's it called again?
Dispatch. Our URL is dispatchlabs.io. Dispatchlabs.io/discord is a great place to get in direct contact with core devs.
All right. Zane, Brewster, Anatoly, Dan, Mark, everyone else who presented today, thank you so much for finding the time to come here, all of you for participating in the pizza eating, in the beer drinking, and the great questions. And feel free to hang around and enjoy the great company, and thank you for being here.